Okay, let's do the example 7. Okay, that is f of x is equal to sine x. Now find the derivative of sine x at x is equal to 0. Okay, so first principle, f dash of x is equal to limit h tends to 0 f of x plus h minus f of x on h. Okay, so this will be f dash of x will be, f of x is this, f dash of x will be limit h tends to 0 sine x plus h minus sine x upon h. Okay, all the x will be added with h. Now limit h tends to 0. Now putting the value of h, will have no, not putting the value, no, sine so this is the form f dash of x. Now at x is equal to 0, so we'll have f dash of 0 equal to limit h tends to 0 sine 0 plus h minus sine 0, okay, upon h, which is equal to limit h tends to 0, so this will become sine h. Sine 0 is sine 0 degree is 0. Okay, so minus 0 upon h, so it will be limit h tends to 0 sine h upon h. Okay, now you know the theorem, that is a limit x tends to 0 sine x upon x is equal to 1. Okay, now this is in the same form. Okay, sine h upon h tends to 0, so this is 1. Okay, now we'll do it in the power rule method. So assuming y is equal to, we can write this as f of x is equal to, we can write this in this form, y is equal to sine x. Okay, at x is equal to 0 again, so dy by dx of x power n is n into x raised to n minus 1. Okay, this is the power rule method, the formula. So y is equal to sine x, so dy by dx is equal to, you know the dy by dx of sine x is cos x. Okay, yeah, we have learned the formula, sine x is cos x. So dy by dx of sine x at x is equal to 0 is equal to dy by the sine x is cos x. So at x is equal to 0 means x will be 0, so we can put cos 0. You know that cos 0 degree is 1. Okay, that's it, same answer. Okay, now let's do the next. Okay, let's do the 9th example, that is the find the derivative of the function f of x is equal to 10x. So again the first principle method, so let's put it will be limit f dash of x will be limit h tends to 0 10, and so in the formula if we put it 10 x plus h. Okay, x plus h minus the function as it is, that is f of 10x upon h, which is equal to limit h tends to 0 multiplying 10 inside 10x plus 10h minus 10x upon h. 10x and 10x will get cancelled. You have limit h tends to 0 10h upon h. Now h and h goes, you have limit h tends to 0 10. So limit of the constant is constant 10. Okay, so 10 is the derivative of the function f of x is equal to x. Now this power rule method again, let it be y is equal to 10x. So the formula dy by dx of x, so the derivative of x power n is equal to n into x raised to n minus 1. Okay, so dy by dx is equal to d by dx of 10x, which will be, now constant can be brought out, so 10 d by dx of x. Now we know the variable having power 1 is always 1. Okay, so it's 10 into 1, which is equal to 10. Okay, that's it. Let's do the next. Okay, find the derivative of the function f of x is equal to x squared. Again, first principle. The formula is, f dash of x is equal to limit h tends to 0 f of x plus h minus f of x upon h. Okay, so f of x is equal to x squared, so f dash of x is equal to limit h tends to 0, so x plus h whole square, adding h to the x. Okay, and the function as it is x square minus x square upon h, which is equal to limit h tends to 0. Now a plus b whole square, x square plus h square plus 2xh minus x square upon h. Okay, now positive x and x square and negative x square get cancelled. You have the remaining, that is limit h tends to 0 h square plus 2xh upon h. Okay, so you can take h common here, so it becomes limit h tends to 0 h into h square plus 2x upon h. This h and h get cancelled. You have limit h tends to 0 h square plus 2x. Sorry, it's not 2x. Yeah, 2x. Okay, 2x. Now putting the value of h in the function, you have 0 square plus 2x, which is equal to 2x. So this is the derivative of x square. Okay, now we'll do it in the second method. Let the function be y is equal to x square, so dy by dx is equal to dy dx of x square, which is equal to this in the form n into x raised to n minus 1. Okay, so 2x raised to 2 minus 1, which is equal to 2x raised to 2 minus 1 is 1, so it's 2x. Okay, that's it. The 12th one, f of x is equal to 1 by x, so the derivative of this function. Okay, so f dash of x is equal to limit h tends to 0 f of x plus h minus f of x upon h. Okay, first principle of derivative. Then you have f dash of x is equal to, so here instead of in the x you have add h. Okay, so it will be 1 by x plus h minus function as it is 1 by x upon h. Okay, limit h tends to 0. Now which is equal to, now in the numerator part let's take LCM, so it becomes x plus h into x, so this will be x minus x plus h. Okay, upon h, limit h tends to 0. Now if you see, this becomes limit, okay, let's x minus x minus h, okay, upon x plus h multiplied of x, and let this h can be written as 1 by h. Okay, now this positive x and negative x get cancelled, this h and this h get cancelled, you have minus 1, so limit h tends to 0, here also limit h tends to 0. Okay, minus 1 upon x plus h multiplied by x, so this can be written as limit h tends to 0 minus 1 upon including x square plus xh. Now putting the value of h in the function, we have minus 1 by x square plus x into 0, which is equal to minus 1 by x square. Okay, that's it. This is the derivative. Now by doing in the second method, you have y is equal to 1 by x, so dy by dx is equal to dy by dx of 1 by x. Now this can be done in two ways, that is 1 by x can be taken as u by v whole dash. This is considered to, this is, we assuming this to be u and this to be x. Okay, u by b, or simply this is one method, or simply making this one as taking the x to the numerator. It will be x raised to minus 1. Okay, now d by dx of x raised to minus 1, again in the form n into x raised to n minus 1. We can do this. So this will become minus 1 x raised to minus 1 minus 1. Okay, which is equal to minus 1 x raised to minus 2. Okay, now bringing the x raised to minus 2 to the denominator, you get minus 1 by x raised to x squared. Okay, that's it. You got the same answer. See, now we already have in the formulas that d by dx of 1 by x is equal to minus 1 by x squared. Okay,